This is Differentiation Lesson 2, Basic Rules for Differentiation. So we're going to look at some important rules which you need to follow when you're differentiating a function. If f of x equals x to the power n, then f dash x will be n times x to the power n minus 1. So with all of these, we'll illustrate with an example. What we're saying here is that if f of x were a function like x cubed, so if f of x equals x cubed, what we want to do then is we want to find the derivative. We call that f dashed x, and that will equal 3x squared. We've multiplied by the power 3, and we've dropped that power by 1. Important to know that if f of x is just a constant, so it's just a number, here we're calling it c, then f dashed x will be 0. An example would be if we have f of x equal, let's choose a number, say 7, then f dash x here must be 0. The derivative of a constant is always 0. Why is that the case? Well, we can think about 7 as actually 7 multiplied by x to the power 0. So we're saying here that any constant could be written as the constant times x to the power 0, and if we multiply by 0, if we bring that power down and multiply, we're going to have the answer 0. Down below on the left now, if f of x equals a times x to the power n, then f dashed x is actually just a n x to the power n minus 1. Let me explain that a bit clearer. So this time, if f of x is not x cubed, but happens to be 5x cubed, so we've got this value a in front of the x term, well, we can still differentiate as we did before, so it'll just be our 3x squared, but we have to times by the 5. So 3 times 5 is 15, and then drop the power by 1. And the last rule that's going to be important in this particular video is if f of x is g of x plus h of x, then we can actually differentiate those one by one. So what we're saying then is if f of x happens to be something like f of x equals, let's have x cubed again, so f of x equals x cubed plus 2x, and then maybe plus 7. What we're saying here is that if there are a number of terms, we can differentiate term by term, one at a time. So here, f dash x would equal 3x squared, as we know, and then we would just differentiate the next term. The derivative of 2x would actually just be 2, because the power is 1, so you're multiplying by 1, and that leaves you 2, and then x to the power 0, which is just 1, so it's 2, and the derivative of 7, of course, is 0. So these are 4 key ideas, but of course applying them can be a bit more difficult. So let's look at a series of examples that might help you to understand how to proceed. Okay, let's look at our first set of examples. Now it's important you do pause the video if you are confused or want to take a bit more time, as I may be a little brisk making my way through these. F of x equals 3x to the negative 2. So our derivative, f dash x, we follow the rule that we multiply by the power. The power happens to be a negative value, but that's okay. So negative 2 times 3 is negative 6, and then we drop that power by 1. This will be negative 3. What we need to do, though, is to write that with a positive power, so that'll be negative 6 divided by x cubed. It's important that we do leave our answer with a positive power for some of the questions that occur later in this topic. G of x equals 1 over x to the power 7. Here it has a positive power, but it's not ready for differentiation. We need to write it as x to a power on the top, so we have x to the power negative 7. Now we can differentiate. So we have g dashed x equals, multiply by the power, that'll be minus 7x, and drop the power by 1. Power will be negative 8. We must write this with a positive power now, so we're going to write that as negative 7 all over x to the power 8. It's important that we do that in these questions, particularly in some of the later aspects of this particular topic. Third example here, f of x has a fractional power, so it's x to the power 3 over 2. So the derivative, we follow the rule again, we multiply by the power. This time it's a fraction, so it'll be 3 over 2 multiplied by x, and the power needs to drop by 1. 3 over 2 is 1.5. 1.5 take away 1 would be 1/2. Now, this is a fractional power. We want to change that back into a root to make our answer a little bit more easy to work with. So that would actually be 3 over 2 times the square root of x. We know that power 1/2 just means square root. And we could even write this as 3 square root x all over 2. They are the same thing. Okay, on to our fourth example. F of x equals the fourth root of x cubed. To differentiate this, we need to write it as x to a power. So we change our expression to x to the power 3 over 4, as we should know from National 5, and then we're ready to differentiate. Here we follow the rule, f dash x will be multiplied by the power, which is a fraction, and drop the power by 1. Now 3/4 take away 1 is -1/4. A little bit more difficult, but we need to try and write this with a positive power. So that's 3 over 4 and then x to the power 1/4. And even better if we can then change that to a root. So that's actually 3 over 4 times the fourth root of x. That's important, but it can be quite difficult to do. H of x equals 5x cubed plus 1 over 3 root x is our next example. Again, we need to prepare it for differentiation. So this term is fine, 5x cubed is ready to differentiate. But the other term, we need to change that root to a power. So it'll be 1 over 3 times x to the power -1/2. It would be x to the half, and we bring it up, so it's x to the -1/2. Then we differentiate, only then do we write h dash x equals 15x squared, and then we take care with the more difficult part. We're going to multiply -1/2 by 1/3, so that will be -1/6, and then we drop that power by 1, so it becomes -3 over 2. And we're going to try and write that with a positive power. So that will be -1 all over 6, and then that'll be x to the power 3 over 2. And we can write that as a root. So that's 15x squared minus 1 over 6 times x to the power 3 over 2, of course, is the square root of x cubed. Okay, in our sixth example, we have f of x equals x cubed bracket the square root of x plus 1 close bracket. So we're now looking at what happens if we have some products where we have to multiply some terms before we can differentiate. So in order to do this, we're going to, first of all, rewrite the root x as x to the power 1/2. Everything else staying the same. Then we're going to break the bracket. So x to the power 3 times x to the power 1/2. Well, 3 is, of course, 6/2. So this would just be x to the power 7 over 2. So we don't want to write x to the power 3.5. We want to write that as a top-heavy fraction, 7 over 2. And then multiplying x cubed by 1, of course, is just x cubed. Now, of course, it's in the form that we want, and we're ready to differentiate. So we would write f dashed x equals, and we would use the rule. So we multiply it by the power. That would be 7 over 2. And then x to the power, well, we're going to drop this power by 1, which is actually 2/2. So it drops down to 5 over 2. And x cubed, of course, is just 3x squared. We talked about that at the very beginning of this video. So all that's left to do is to rewrite that as 7 over 2 multiplied by the square root of x to the power 5 plus 3x squared. So we're now going to do 2 more examples, a little bit more difficult, but hopefully you're feeling a bit more confident and you're able to try and do this on your own. Okay, in our 7th example, we're going to look again at a product, but a bit more complicated. H of x equals x minus 1 over x squared, in brackets, multiplied by x plus 1 over x squared. So the first thing we want to do here is to consider 1 over x squared and rewrite that as x to the power -2. By doing that, it's probably easier to break these brackets. So using FOIL, where we would multiply the first two terms together, so really we're multiplying x by x here. Breaking the brackets using FOIL, we would get x squared. And then, of course, we continue using FOIL, so we multiply the outside terms, x multiplied by a positive x to the negative 2. Well, we're adding the powers. The power with the x term is just 1, so 1 minus 2 is minus 1. And then in the middle, we have the same thing, but with a negative front, so it'll be negative x to the negative 1. And at the end, we get minus x to the negative 4. So it might be worth pausing the video and thinking about how we got those answers. We know that these two terms cancel each other out. This was actually a difference of 2 squares arrangement. And here we get x squared minus x to the minus 4. And only now can we differentiate. And actually, the derivative is fairly simple. It's 2x, and then negative 4 times negative 1 is plus 4, x to the negative 5. And as always, we finish with a positive power. So we're going to write that as 2x plus 4 over x to the power 5. So these ideas can be difficult if you're not as confident with your indices, but that's something you can review, and you can certainly go through the video much slower to try and work out some of those steps. Last example, g of x equals 3x squared minus 5x plus 2 all over the square root of x. So as before, I'm going to change the square root of x to the term x to the power a half. Now, how do we approach a quotient like this? Well, we break this fraction up into 3 separate fractions. So we can say that that's 3x squared over x to the half minus 5x over x to the half plus 2 over x to the power a half. So we can separate that into 3 fractions, all with that same denominator, and then we can evaluate each term. So 3x squared over x to the half, we're going to subtract the powers, it'll be 3x to the 3 over 2. Here, in the next term, we're going to have minus 5x to the 1 half. It's just 1 minus 1 half, so it'll be 1 half. And finally, we'll have 2x to the negative 1 half. So that can be quite difficult, but once we've done that, the differentiation isn't too difficult. We just find that g dashed x, for this problem, that will be 3 over 2 times 3 is 9 over 2, x to the 1 half. Remember, we're dropping that power by 1. Minus 5 over 2, x to the negative a half. And then minus x to the the negative 3 over 2. So negative x to the power negative 3 over 2. And finally, we're going to rewrite this so that we have fractional powers changed to roots and any negative powers changed to positive powers. So this will be 9 over 2 times the square root of x minus 5 all over 2 times the square root of x, and then minus 1 over, and that'll be x to the 3 over 2 on the bottom, which is the square root of x cubed. So I've really tried to cover quite a range of difficult questions in this lesson. You will get some practice when you proceed to your textbook. You'll go at a much slower pace, but hopefully you'll be able to follow many of these examples and get some idea of how to proceed. It might be that you need to return to this lesson once you get through some of the easier questions. Good luck. Okay, it's important that you practice differentiation, and you'll be able to do that using your textbook. Take it slowly, move through the questions as they increase in difficulty. TG textbook, you really want to look at page 32 and 33. So that's exercise H4.2 and H4.3. And the first one, I would only really do questions 1 to 29, but all of 4.3. And for those of you who are using the Heinemann textbook, then you want to be looking at page 94 and 95. That's exercise 6F and 6G. And remember that there are other lessons in this video series. This is lesson 2 of the first 5 differentiation lessons. But really we need to get this basic rule or these basic rules successfully down. So good luck with your exercise questions. Make sure you get support from your teachers and you'll be absolutely fine.